You can see the multiplication is easy here. So 13 into 15 for me, I just need to do 13 into 15. People who know mathematics very well, 13 into 15 is, 130 plus 65, right? 13 tens is 130, 13 fives is 65. 130 plus 65 for me is 195. You have 195 this side, 25 sevens are. 25 sevens is how much? 25 eights is 200. Sevens will be 175.
It will be 125.
175, right? 175. Right? So which is greater? So immediately you know between these two, this is greater. Right? So you know that 13 by 25 is greater than 7 by 15. Okay. So by the way, guys, this method that I'm teaching you is in a situation where you get some tough questions and you have less time. But otherwise, the regular method that you're supposed to do in school is you have to make your denominator common, get to all the denominators in the common, simplify, and get to the answer. So I'm teaching you a faster way of solving. That's it.
But sir, if the teacher doesn't mention the method, then you can do it any way you want to.
Correct,
but you have to get it correct.
Right, correct. So that is there. Now between these two numbers, let's do between these two numbers. Let's do this. 25 11s are 25 10s is 250. So 25 11s will be 275, and 13 19s will be 15 square minus 2 square, 225 minus 4, 221. Is that right? I'm doing mental math. Okay. So between these two, which one is greater? This is greater, right? So your 11 by 19 is greater than 13 by 25.
And now, sir, it becomes easy, sir.
And from here it is very easy.
But sir, you gave it the same. Like you gave it the same way it was supposed to be arranged.
Yeah, that's fine. So you can see between these two, 11 by 19 is greater between these two. So 13 by 25. You have learned in your basic schooling already. I think you know this before. If x is greater than y and y is greater than x, sorry, y is greater than z. If x is greater than y and y is greater than z, that will imply that x is greater than z. Yes or no? Very simple. 100 is more than 75 and 75 is more than 50. Therefore, I can say that 100 is more than 50. So that's the logic. This is something very important that everyone should be knowing. This also holds good in rational numbers also. If x is greater than y, if one rational number is greater than the second rational number, and the second one is greater than the third one, and the first one is greater than the third one. Yes, we have learned it in computer applications. Brilliant. So from here, you can quickly say that your 11 by 19 is greater than 13 by 25, and that is greater than 7 by 15. Or you can also write this as 7 by 15 is less than 13 by 25 is less than 11 by 19. Does that make sense to all of you? Brilliant.
Yes, sir.
Okay, good. So now let's learn what is called rational numbers between any two rational numbers. So tell me, if I take any two rational numbers, say let's take this is rational number 1 and this is rational number 2. How many numbers will exist between any two rational numbers? How many rational numbers can be there in between any two rational numbers?
Infinite.
Indefinite.
Yeah, infinite number, not indefinite, infinite. I mean,
Yeah, infinite.
So,
yes.
So we can have infinite number of rational numbers between two rational numbers. Okay. So there is a method that in school you are supposed to learn a particular method that's called a mean method of introducing rational numbers between any two rational numbers. What is that mean method? Let's learn that. So if I want a rational number, I can take any rational number between R1 and R2. So a mean average of these two will be, can I say, another rational number. So let me call that rational number for a moment as Q1. So that rational number Q1, I can write it as R1 plus R2 by 2. So if I calculate R1 plus R2 by 2, I get a rational number in between them. So that is your Q1. So let me take an example and explain.
Sir, the Q1 actually looks kind of like 2-1.
What?
Sir, the Q1, sir, the Q actually looks like 2.
Okay, okay. That's fine, that's fine. Don't worry about all that, Arya. So focus on the class. Okay, good. So now let's assume we have number 0 and 1. So we have 0 and 1. So if I want to introduce a rational number between 0 and 1, so what do I do? So let me call that rational number as say Q1, which is nothing but 0 plus 1 divided by 2. So 0 plus 1 is nothing but 1. So you have 1 by 2. So you got a rational number between 0 and 1, that is 1 by 2. Okay. So now if I want more rational numbers, so one is I can take a rational number between Q1 and R2, which is a mean of that I can calculate here. I can also calculate another rational number between R1 and Q1. I can do this or I can do that. Okay. So let's assume I want to do this and let me call it as Q2 here. And let me call this as Q3 here. I'm just naming them. Don't worry. I'm just naming them. Okay. Now where is Q2? Now Q2 is between R1 and Q1. So how do I calculate Q2? Can anyone tell me how can I calculate Q2? Yes. What is Q2? Anyone in the class? How do I get Q2? I'm using the mean method, average mean method. Anyone?
Yes, R1, Q2 is R1 and Q1 divided by 2. R1 plus Q1 divided by 2.
Wonderful. It should be R1 plus Q1 by 2. So how do I get Q3?
Q1 plus R2 divided by 2.
Very good. It should be Q1 plus R2 divided by 2. Wonderful. So let's apply the same logic. We already got Q1 here. Let me calculate Q2. Yes, can you tell me how do we calculate Q2? Yes, that will be 0 plus 1 by 2 whole divided by 2. Yes or no? We already got Q1. Therefore, I'll calculate 0 plus 1 by 2 by 2. What is 0 plus 1 by 2 is 1 by 2. 1 by 2 whole divided by 2. What is that? 1 by 2 whole divided by 2. What will be the value? 1 by?
1 by 4.
Wonderful.
1 by 4,
it'll be 1 by 4. So anyone finds it difficult to understand this? 1 by 2 divided by 2 will give you 1 by 4 because that 2 goes down, right? So basically it's 1 by 4. So you got this 1 by 4 here. So similarly, can you get this number quickly? So what is your Q3 now? Calculate Q3. Q3 will be a mean between 1 by 2 and 1. Calculate. 1 by 2 plus 1 whole divided by 2. 1 by 2 plus 1 whole divided by 2. What will that be? That will be nothing but 3 by 2 whole divided by 2. That is 3 by 4.
Yeah.
Okay. So you can keep on calculating like this. So if someone asks you to calculate, say if someone asks you to insert 3 rational numbers, you can put 3 rational numbers. Someone asks you to insert 5 rational numbers, you can put 5 rational numbers. So calculating is not a big deal. So here, my purpose of this is not to teach you how to do this because this is something very simple, which most of the students in school know it. But one very interesting and most important thing that I want everyone in this room to understand is if I have any rational number here, another rational number here, I can calculate a mean rational number by adding those two divided by 2. That's point number 1 I want everyone to learn. So let me take this as a rational number 1 and this as rational number 2. So I'm saying you have 1 here. So that's a mean. So now if I keep on doing this, if for example between now this, let me call this as rational number 3 for a moment. Now between R3 and R2 I can create one more here. Now between this, let me call it as R4. Between R4 and R2 I can create one more here. Right? Let me call that as R5. Now between R5 and R2, once again I can create 1. So like that, if I keep on doing it.
So you can keep on doing it, sir, like forever.
Yes. So the point is you can have infinite number of rational numbers between any two rational numbers. That's the point I want everyone not only understand, but remember this for your lifetime. Does that make sense? That's the reason you can say there are infinite number of points on a rational number. Okay?
For example, it can be between 3 and 4. So, for example, we have a very famous irrational number. It's 3.14, sir, and then it keeps going on like the number forever.
Correct. Yeah.
So just one thing. So not only are whole numbers infinite, but between two whole numbers there's another infinite?
Yeah.
That's what you said.
Can you repeat?
What I'm saying is,
what's your question?
I said not only are numbers infinite, that means 1, 2, 3, 4, so on, but numbers between them are also infinite. That's what you suggested.
Correct.
Yeah.
Correct. Okay. So now, how many rational numbers are there between 3 by 10 and 7 by 10? So there is nothing to worry. You know, infinite numbers. There is nothing.
You can keep going on.
Yes. So if someone asks you how many rational numbers are there between 3 by 10, then it should be infinite number. Wonderful. Good.
Between 3 by 10. Oh wait, no.
Yeah.
Sorry. I'm sorry.
No problem. So operation on rational numbers, these are all very simple things. These are very academic in nature. I just need to teach you how to do addition. But trust me, I need not teach you. You're already there. You're already doing it. But let me still do it for you. So if someone asks you to add 3 by 5 and say 2 by 3, how do you add that? You bring it to the same LCM.
So
you calculate.
Find the LCM, which is 15.
LCM and then add. LCM
Yes,
add.
Correct. LCM is 15 there. 5 3s are, 3 3s are is 9.
9 plus
3
10.
5s are and
No,
5
sorry,
2s are is 10.
15. Sure, which is 19 by 15. Which you can convert it into a mixed fraction or decimal, but mixed fraction is better.
So should I assume all of you know how to do this? Addition of two rational numbers?
Yes, sir. We practically know how to do it.
Yeah. So good. So let me not waste time on addition of rational numbers. So let me go to subtraction. Now, subtraction of rational numbers, similar. Say, for example, you have 8 by 15 and say 3 by 7. I need to subtract this. How do I do it once again? Same logic. 15 sevens
just find LCM and then subtract. And then
correct. So you have 15 sevens. Yeah. Okay. Just hold. I know you guys know it. I'm quickly going through it. So 15 sevens are 7 8s is 56 minus how much? 15 threes is 45 there. So that will be 11 upon 105. Okay.
Mr. Krishna, I'm very sorry to interrupt.
Yeah.
Wait, I forgot what I was gonna say. Never mind. Just continue.
Okay. Good. So these are simple operations. Now multiplication. I hope everyone knows multiplication. If I want to multiply.
Yes, sir. You just showed it. Showed us to it now.
Yeah,
so
cross multiply. 3 times 5 and 2 times 7, and then you find the answers. Yeah.
Wonderful. So your numerators get multiplied simply. So 2 5s is 10 and 3 7s is 21.
21, sir. Pretty easy.
Correct. So in case if you have something like 2 into 3 multiplied by 6 by 7. So if there is a common
3 times 6.
So but when basically you have a common factor, can I cancel these two common factors like this?
Yes, sir.
Yes.
It can be 4 by 7.
Yes. So basically it will be 4 by 7. The reason for that is very simple. If you were to do it normally, it is 2 6 are 12.
Yeah.
2 6 are 12 by 3 7s are 21. But you can see there is a common factor between 12 and 21, which is 3. So basically 3 4s are.
I'm sure you have to simplify it further if they're asking us to simplify it.
Yes.
So we have to simplify it further, which would take more time.
Wonderful. So everyone understands this. So I'm going further. I'm not wasting time with these things. If anyone needs help on these things also, I'm happy to help. Post me separately on the private chat. I can always respond to you. Okay, if you're uncomfortable in the class explaining, sir, you have anything that you want to share with me, not in the public chat, there's a private chat you can share with me. Okay, good. So let's go division of rational numbers. If we have 2 by 3 to be divided by say 5 by 6 or 5 by 7. So there's nothing to worry. So basically what you're doing is you're doing 2 by 3 by 5 by 7. So what happens is this 2 by 3 is here. This 5 by 7 comes to the numerator. It reciprocates.
It reciprocates to 7 by 5, and then you have to do 2 times 5 and 3 times 7.
Very good. So that will be 2 by 3 by 5 by 7 will be 2 by 3 into 7 by 5. This reciprocates. Right? So therefore, this will give you 2 sevens of 14 by 3 fives of 15.
Also, sir, instead of doing all of that, you can just do direct multiplication. That means before you reciprocate, you can just do 2 times 5 and 3 times 7. Even that works.
Yeah. It's one and the same, but you just need to understand first before you to do it faster.